All right, this is day 3 notes for Unit 7, the third day of the semester. We are still working on solving polynomials that are not factorable. So the example I go through today is very similar to the ones you saw yesterday. In class, though, we will do one new thing. So just a reminder, your steps to solving unfactorable polynomials, you're going to use synthetic division to divide the polynomial down to a quadratic. Remember, a remainder of 0 means the divisor is a factor or a solution. So once we have a quadratic, we will find the remaining solutions using either factoring the star method or the quadratic formula. And we're going to come up with what we divide by using our P over Q list. Here I have 2x cubed minus 9x squared plus 2. The first thing I want you guys to notice is I'm missing a term. So remember, for synthetic division, if you're missing a term, you need to write that you don't have any of them. So I have 2x to the third minus 9x squared, and then I have 0 x's, but then I have my 2. So from here, we're going to come up with our P over Q list. So P is 2 and Q is 2, which means my factors for P are 1 and 2. My factors for Q are also 1 and 2. So 1 over 1 is 1. 2 over 1 is 2. 1 over 2 is 1/2. And 2 over 2 is again 1, which is already in my list. So these are the 6 possible numbers that I could divide by when I use synthetic division. So I'm going to go ahead and set up the problem starting with 1. And I have 2, -9, 0, 2. So I run through this really quick. Right away, I know that this will not cancel out to 0, so I'm going to move on to the next one on the list. To save a little bit of time, since you guys saw all of this yesterday, -1 doesn't work, 2 doesn't work, and neither does -2. The first number that does work is 1/2, so we're going to skip to 1/2. The only reason I know this is because I did this example already with paper. So again, there's no shortcut, there's no quick way of telling this. I just already worked it all out, and I'm just letting you guys skip this part of the notes. So we're going to do the synthetic division. I drop down the 2. This will give me 1, so that's -8. 1/2 of -8 is -4. When I add those together, it's -4. Half of -4 is -2, and 2 and -2 is 0. So my remainder is 0, which means 1/2 is going to be one of my answers. And then I'm left with my constant, my exponent of 1, and my exponent of 2. So my quadratic for this problem is going to be 2x squared minus 8x minus 4. If I try to factor this, I take out a GCF of 2, which leaves me with x squared minus 4x minus 2. And if you try to do the star, there are no 2 numbers that multiply to -2 but add to -4, which means I have to use a quadratic formula. So I have x equals the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2a. So we first simplify everything underneath the square root. So this will give me 8 plus or minus the square root of 96 all over 4. So that's step 1. Step 2 in simplifying the quadratic formula is breaking down what's underneath the root. 16 is the biggest perfect square that divides into 96. 16 and 6, and then that breaks down into 4 and 4. So my pair 4s go on the outside, and the loner stays inside. So I have 8 plus or minus 4 square root of 6 all over 4. And then the last step is to divide out the triangle. 8, 4, and 4 all have 4 in common, so I'm left with 4 plus or minus the square root of 6. So my answers here would be x equals 4 plus the square root of 6, x equals 4 minus the square root of 6, and x equals 1/2. So I have 3 solutions, and if I look up at the original problem, I started with a degree 3 polynomial. So the 3 solutions tells me that this is correct. Since this is the same thing we did yesterday, I'm only doing one example for you guys, so you have one try on your own, and we'll continue working on this stuff in class tomorrow.